So reporting category 2 is called representational tools to solve problems. So this is factoring, properties of exponents, solving systems of equations, solving quadratics, quadratic formula, using matrices to solve systems, and graphing inequalities, systems of inequalities. So we're going to start by talking about factoring. And there are two main factoring types that we talk about, and that is GCF. GCF stands for greatest common factor. It's where you have something like 5x minus 15, and you find the GCF. What's the GCF of 5 and 15? 5. So that would be 5 and then x minus 3. And you could distribute it back out to make sure you factored it correctly. The other kind of factoring that we talk about is my father drives a red Mustang. And my father drives a red Mustang is multiply, factor, divide by a, reduce, and multiply. So if we have something like x squared minus 12x plus 27, we multiply a and c. So 1 times 27 is 27. And then we look for two numbers that multiply to 27 and add up to negative 12, and they would be 9 and negative 9 and negative 3. Divide by a, so divide by 1, divide by 1. We can't reduce that because we're just dividing by 1. And then we make our factors by reading from the bottom up. X minus 9, x minus 3. Remember, if there's a number in front of that x squared, you have to divide by it. That's the most common mistake in factoring. So the next thing we're going to talk about are all the properties of exponents. So if we're multiplying x squared times x to the third, x squared times x to the third, x squared is x and x to the third is xxx. If we're multiplying all of those, how many x's do we have in all? We have 5. So what did we do with the exponents? We added them. So when you're multiplying two things that have exponents, if they have the same base, then you add those exponents. Dividing looks like this. If we have x to the 5th over x to the 7th, that means we have 5 x's on top, 7 x's on the bottom, 1, 2, 3, 4, 5, 6, 7. What happens to those x's? They cancel. Those cancel, those cancel, those cancel, those cancel, those cancel. And we're left with x squared on the bottom. And what has to go on top? A 1. What did we really do with the 5 and the 7? We just subtracted those, and you put the leftovers where the bigger group is. Power to power looks like this. If we have x to the third to the 4th power, this power to power, I think of it like distributive property. I multiply those, and it equals x to the 12th. Negative exponents, if you have x to the negative 5th, negative exponents, you think about putting it over 1, and then you do the reciprocal. So negative exponents, you do the reciprocal. The reciprocal of that would be 1 over x to the 5th. And when you do that reciprocal, that exponent becomes positive. Anything to the 0 power equals 1. So 5 to the 0 is 1, x to the 0 is 1, 72 to the 0 is 1, anything to the 0 is 1. The next. Complex numbers, excuse me. Complex numbers include radicals and imaginary numbers. The most common place we see complex numbers is when we do the quadratic formula. Quadratic equations are in the form ax squared plus bx plus c equals 0. We solve quadratic equations by factoring, by graphing, and by using the quadratic formula. Now, the quadratic formula, I'm not going to write it on here because it's on your formula chart, and you all should have one of those. So we can factor, we can graph. When you graph, you have to put the equation in y1, and then y2 equals 0. And then you use the second trace and find where and calculate where they intersect. So the equation that you're trying to solve, you put that in y1, put 0 in y2, and then second calc trace number 5. And you have to hit enter, I think, 3 times. So the next vocabulary is systems of equations. Systems of equations are 2 or more equations. We solve systems mostly by graphing and matrices. We could do substitution and elimination as well. I think for the EOC it's probably going to save you more time if you graph or do the matrix method. And especially if you have a system with 3 variables, then you definitely want to do the matrix method. For the matrix method for matrices, so we're going to talk about matrices to solve systems. That's where you do matrix A inverse times matrix B. So the inverse of A times B, you enter the one matrix into matrix A, the other one into matrix B, and then it's A inverse B. Systems of inequalities, you graph everything. Remember, less than and greater than are dotted lines. Less than or equal, greater than or equal, solid lines. Greater than and greater than or equal, shade above. Less than or equal, shade below. So that's all the vocabulary in this section. So let's look at some questions. So question number 1, read that quietly, or read that to yourself. I guess you don't need to read it quietly. I don't care if you read it out loud because you're watching this on your own. So when Doris shines her flashlight on the wall at a certain angle, the edge of the lit area is in the shape of a parabola. The equation of the parabola is y equals 2x squared plus 2x minus 60. That is not on your paper. You need to write that down now, please. Pause the video if you need to, or just keep on going, but write it down. The question is, or the thing that we have to do, is factor that equation. So if I want to factor y equals 2x squared plus 2x minus 60, remember when we did our vocabulary, we talked about 2 ways to factor, GCF and my father drives a red Mustang. GCF is what I have to look for first. So when I look at this, 2x squared plus 2x minus 60, is there a GCF? Yes, 2 goes into all of that. So I put 2 and then x squared plus x minus 30. Because 2 times x squared is 2x squared, 2 times x is 2x, and 2 times negative 30 is the negative 60. Now from that, I have to factor this x squared plus x minus 30. And to do that, I do the my father drives a red Mustang. So 1 times negative 30 is negative 30. Then I'm looking for 2 numbers that multiply to negative 30 and add up to 1. So negative 30. 30 is 1 and 30, 2 and 15, 3 and 10, 4 doesn't work, 5 and 6. There it is, 5 and 6. But to get a positive 1 out of that, it has to be positive 6 and negative 5. So that's the my father. The drives A means divide by A. So I look in front of the x squared. In front of the x squared, there's a 1. So divide by 1, divide by 1. And then the reduce, I can't reduce either of those. So I make my factors by reading from the bottom up. But remember that 2 that's out there, I'm going to bring that down. And then x minus 5 and x plus 6. So that is our function in factored form. Now, the reason why we factor quadratics is so that we could find our solutions where that graph would cross the x-axis. In this case, it didn't ask us to do that, but that's the main reason why we factor. So let's look at problem number 2. Problem number 2, and it might be hard to read on your screen, so I'm going to write it a little bit bigger, is 45 x to the negative 5th, y to the 3rd, z to the 0, over 70 x to the 6th, y to the negative 3rd, z to the 7th. So that's, I just rewrote it so maybe you could read it a little bit better, because again, it was left off your paper. And I know it's hard to see on that video. So the first place we want to start is with those negative exponents, because those negative exponents have to be moved. This x to the negative 5th, remember negative exponents, you think about putting it over 1 and flipping it. So those that x to the negative 5th is going to move to the bottom and become positive. So they're no longer on top. They went away and they got moved to the bottom. So I put them right next to the x to the 6th because they're both x's. Then this y to the negative 3rd, that needs to be moved as well. That has to go to the top. So I move that up to the top. Now I can start simplifying things because everything now has a positive exponent. The 45 over 70, we have to reduce that like we do any other fraction. What number goes into 45 and 70? 5 does. Is there anything bigger than that? Anything bigger than 5 that goes into 45 and 70? I don't think so. So let's go with that. So 5 into 45 is 9. 5 into 70 is 14. And if you have your calculator, if you have a graphing calculator in a way, you can type in 45 divided by 70, math enter, enter, and it will reduce for you. Then I'm going to keep going on top because I have two sets of y's there. I have y to the 3rd and y to the 3rd. Y to the 3rd and y to the 3rd makes y to the 6th. And then the next thing I have on top is that z to the 0. Now when we did vocabulary, we talked about anything to the 0 power is 1. So this is really 9 times y to the 6th times 1, which is just 9y to the 6th. So I don't need that 1 up there. So that is essentially just going to go away. So that z to the 0 essentially just goes away. And on the bottom, I already reduced the 70. Now I look at my x's. X to the 5th and x to the 6th makes x to the 11th. And then the z to the 7th, there's no other z's anywhere else in our problem, so they stay there. So I took it thing by thing by thing. I started with the negative exponents, then I reduced the numbers, then I looked at my x's, I looked at my y's, then I looked at the z's, and I just reduced everything. Number 3 says solve the following quadratic using the quadratic formula. And again, I'm going to rewrite it because I know it's hard for you to see on the screen possibly. It's 2x squared minus 4x plus 5. And we have to solve that using the quadratic formula. The quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And now, we did talk about that there are other ways to solve quadratics. We could graph, we could factor, but because this specifically says to use the quadratic formula, we have to use the quadratic formula. When you're doing your EOC test, being that it's a multiple choice, you'll know when to use the quadratic formula if there's a square root in the answer. Whenever there's a square root still in the answer, you should do quadratic formula for sure, because that means it can't factor. And if it's a multiple choice and has a square root in it, then you don't want to graph. So what's my A? My A would be 2, my B would be negative 4, and my C would be 5. So I'm going to plug that in. So when it's negative B, and I already have a B as negative, negative, negative makes positive, plus or minus the square root. Now notice that negative 4, I put it in parentheses because we have to square that whole thing. Not just the 4, we're squaring the whole negative 4, so use parentheses, minus 4ac, so negative 4 times 2 times 5, all over 2a, so 2 times 2. So I'm going to move over here a little bit more because I'm running out of room because I write too big. So 4 plus or minus the square root. So negative 4 squared minus 4 times 2 times 5. Negative 4 squared is 16. Minus 4 times 2 times 5 would be negative or minus 40 all over 4. So I'm going to keep going with this. 4 plus or minus the square root. 16 minus 40 is negative 24 all over 4. Now, the square root of negative 24, we have to go to the side of our paper and do that. Square root of negative 24. There's a negative underneath the radical, so what does that automatically mean I have to have? It means I'm going to have an I. Remember, square root of a negative number means I'm going to have an I. And then 24, I break it into 4 and 6. 4 is 2 and 2. 6 doesn't break down, or breaks down to 2 and 3, but there's no square root there. So it's 2i square root of 6. So 4 plus or minus 2i square root of 6. Now, that 4 on the bottom, I'm going to write it underneath both of those pieces, and the reason we do that is so that we can reduce. Because 4 over 4 is 1, plus or minus 2 over 4 would be 1i square root of 6 over 2. And that would be your answer. So quadratic formula is the negative b plus or minus square root of b squared minus 4ac all over 2a. It has to equal 0 so that you can use that. Plug everything in. If you get a square root with a negative, you have to have an I in it. Okay, so number 4. A student-written performance is, that should be playing, not laying. At a local high school, Rochelle paid $52 for 2 adult, 2 student, and 1 child tickets. RJ paid $56 for 1 adult, 2 student, and 3 child tickets. And Harry paid $44 for 1 adult and 4 child tickets. So I'm going to underline those numbers because you don't have those in your packet. So Rochelle was 52, RJ was 56, and Harry paid 44. So we have to, from this, find the cost of each ticket. And the way we do that is set up a system. So we're going to start with Rochelle. Rochelle paid $52, so I'm going to put equals 52. She bought 2 adult, so I'm going to say 2x. She bought 2 students, so I'm going to say plus 2y, and 1 child, so plus z. So over here to the side, I'm going to say x is my adults, y is my children. No, I just said that wrong. Y is my student, and z is my child. That's going to be important for us to remember because we're going to end up solving this using a matrix, so I have to know which one is which. Then RJ paid $56 for 1 adult, 2 students, and 3 children, so plus 3z. And then Harry paid $44 for 1 adult and 4 child tickets. Now notice I left a big space there in the Y spot because he didn't buy any student tickets. So in there I'm going to put 0y. Now to solve this, if you don't have a calculator to do the matrix method, then you could do substitution. You could solve this one for x and plug it in other places and solve it using the substitution method. But I'm going to go ahead and use my calculator. So I'm going to go to matrix. I'm going to go over to edit, and in matrix A is a 3 by 3. And I'm going to enter those numbers 2, 2, and 1 for the first row because it was 2x, 2y, and 1z, and then 1, 2, and 3 for the second row because it was 1x, 2y, 3z, and then 1, 0, and 4 because it was 1x, 0y, and 4z. Now I go back to matrix and I go to edit and go over to matrix B and I enter that it's a 3 by 1. And this is where I put those 3 answers, the 52, the 56, and 44. Now I go back to matrix and I need matrix A. Oops, I needed to quit first. Go back to matrix, go to matrix A, inverse, go back to matrix and get matrix B. So A inverse B. And now that 12, 10, and 8, those are my answers for each of the tickets. and it's in order X, Y, Z. The 12 is the X, so 12 adult. And remember finding the cost, so it's not 12 adults, it's $12 for the adults, $10 for students, and then $8 for a child. So systems, you're going to use the matrix method, A inverse B. Number 5 says write a system of inequalities to represent the graph shown, and that graph is not on your paper, so I'm going to try to zoom it in here so that you can get that. So you need to pause the video for a second and get this graph drawn. I'm going to show you this line. This line has the point 1, -1, and 0, 1. This one is 0, 1, 2, 3, 4, and 1, 5. So there, and there, and there, and there. And so you can use those to help you sketch this graph. So remember, with systems of inequalities, we look at the double shaded area. That's where the solutions are. It's over here. So pause the video if you need to, and then restart it and watch how to write the system of inequalities. So I'm going to start with the line that I'm labeling number 1. So I'm going to start with that line. I just labeled it with a number 1. To write the equation of a line, I have y, and then I'm going to use mx plus b. So my slope, I've got 2 points on that line. My slope, rise over run, I go up 1 and over 1. So it's going to be y and then x. So remember, it's mx plus b, and my b is my y-intercept, so plus 4. Now, in between that y and the x, I need an inequality sign. That line, is the shading part for that line above it, or is it below it? You can see it's above it because this area up here is shaded, so this part right in here is all shaded in. So it has to be a greater than sign. Then I look at that line, and is it solid or dotted? It's solid, so it gets an or equal to. So now I'm going to do the line that I'm labeling with a number 2. So it's that other one. And I do the same thing. I put a y, and I'm going to find my slope. Slope is rise over run. So I'm going to start the 0, 1 and go to the 1, -2. This time I go down 2 and over 1. If I go down 2 and over 1, that means my slope is -2x. And my y-intercept is 1, so plus 1. That line is shaded below it, because you can see it's all this area down here where it's shaded. So it's going to have a less than. And is that line solid or dotted? It's solid, so it gets an or equal to. So that right there is our system. Remember, I will be looking for all of these things when I check your paper.